So we know exponentials, we should know or remember, are y equals ab to the x. And so we're going to kind of go through some stuff before we get to that part. Sorry, people are coming in late trying to admit them. All right, so what we're going to start with here on problem 52, so we've worked with all of these parent functions before. We're going to sketch a graph of each of these. So on your paper, you should be setting up 7 little mini graphs. They are just little graphs, nothing big. And so set up your axes for each of these and then sketch them if you can. And I'll end up showing you mine, but I'll leave this up there for a minute. So again, you're just setting up 7 little sets of axes. Label what each one is. So again, I was saying just set up little axes for each of them, label them, graph them if you can. For y equals b to the x, I just made b2. You could use 2, 3, 5, 4. It doesn't really matter as long as it was a number greater than 1. So we know y equals x squared is just a parabola. Y equals x cubed or cubic goes like that. Y equals x, we should know, is just that diagonal line, y-intercept of 0, slope of 1. Absolute value of x, we know, is that v. Square root of x is half of that sleeping parabola. 1 over x, that was one of the trickier ones. It has the 2 pieces. And then y equals b to the x has that asymptote and goes up that way. So on these same graphs, we're going to also sketch the inverse. So if you have a different color, maybe a highlighter, if you don't have a different color pen or highlighter or colored pencil nearby, do it in like a dash line so you see that it's a little bit different, or you see that it is different. So remember, for a graph to do the inverse, you reflect across the line y equals x. So it's kind of like folding it right here. So the inverse of a parabola we saw was the sleeping parabola. The inverse of the cubic is sideways. The inverse here happens to be right on top of it, because that line y equals x, that is that line of reflection for a function and its inverse. For the absolute value, the inverse is going to be sideways, just how it is for a parabola. It's sideways here. If this right here, the square root, is half of the sleeping parabola, the inverse ends up being half of a regular parabola. Remember, our line of symmetry is this line y equals x. I'm gonna draw it lightly in pencil. So if I fold over this line right here, this point is going to land on this point. And then this point would land on this point and so on. So it ends up being on top of itself. Probably should have drawn this in for all of them. If it's helpful, you can go back and draw it in. And then same thing, if I fold this over, if this is like the 0.01, it becomes the 0.10. This asymptote right there was getting close to the x-axis. Now it's going to get close to the y-axis and look like that. So they want us to also write the equation for the inverse on each of these. So here, and it says in the book, the directions, that the inverse does not have to be a function. They just want to know what the equation is. So we could write this one as x equals y squared, or it's the same as y equals plus or minus the square root of x. So we know a sleeping parabola is x equals y squared, or we can write it as the positive square root and the negative square root. So I'm going to do all my inverses in this blue color to be consistent. Here, the inverse is y equals the cube root of x. Here, it's the same thing, so it's y equals x. Remember, to find a function and its inverse, we can just switch x and y. So this is x equals the absolute value of y. Also not a function. Here, our inverse is half of a parabola, so y equals x squared if x is greater than or equal to 0. We only have half of the parabola, the right half when we have the positives. Y equals 1 over x there. And here, our inverse would be x equals 2 to the y, or x equals b to the y for whatever our b value is if you didn't want to use 2. So y equals x and y equals 1 over x are their own inverses. So we can see that on the graph, the original and the inverse are the same graph. And then for C in the book, it says, do any parent functions have inverse graphs that are not functions? So y equals x squared and y equals the absolute value of x have inverse graphs that are not functions. So that was kind of fast, mostly review. We should have been able to sketch all of these original functions, and you can look back at our big packet of parent graphs. And then the inverse is just folding over the line y equals x. For the equation, you can switch x and y, or you can solve for the variables. But I said we were going to focus on the inverse of an exponential today. So we can write this equation by switching x and y. And we can see what the graph looks like by folding it. But we want to know what this equation looks like in y equals form, because that's how we type it into Desmos. Desmos will actually do this, but graphing calculators, and just to be consistent, we're used to having it as y equals. So for 53, it's telling us to use these three. So we're going to focus on y equals 3 to the x here. So for part A, they want a table for the inverse. So we're going to go ahead and just make a regular table here. I'll just make it from -2 to 2. Move that up for you. So we know if we plug in 0, anything to the 0 power, remember, is 1, not 0. If I plug in 1, 3 to the 1 is 3. If I plug in 2, 3 squared is 9. And remember, negative exponents are the reciprocal. So if I plug in -1, 3 to the power of -1 is 1/3. 3 to the power of -2 is 1/3 squared, or 1/9. So for our inverse, remember, we flip them. Flip our x and y. If x is 1/9, y is -2. If x is 1/3, y is -1. If x is 1, y is 0. If x is 3, y is 1. And if x is 9, y is 2. So again, I'm trying to do all my inverses in the blue to be consistent. Part B wants us to sketch the graph of the inverse. So we're not the original, it just wants the inverse. So it goes through 1, 0, 3, 1. And again, it's going to look a lot like this guy up here. So for part C, I'm just going to kind of extend this table. They're asking if, for the inverse, we don't know the equation. Sure, we can write the equation in x equals form as x equals 3 to the y, because we can just switch our x and our y. But what if I told you that I put in the input is 81 for my inverse? So for part C, the input is 81. So basically the input we know is X. If X is 81, what's Y? So take a minute, see if you can figure that out. If X is 81 for my inverse, this blue graph, this blue equation, what's my Y value? And if you know it, type it in the private chat to me, please. Your best guess is okay also. So again, if I extended my table down here and I said, okay, X is 81, well, what's Y? All right, it looks like we have about half of you so far. Thank you. So yes, Y would be 4. Because here you're kind of asking yourself, 81 is 3 to the power of Y. So how many threes do you have to multiply together to get 81? It's kind of the idea of the same base equations. That's why those were coming back. So 3 to the 4th power gives you 81. So it's kind of thinking about those exponentials in the reverse order. Moving over here. I'm going to flip back to the book so that we can read it, so you can follow along as I read it. It's a little bit longer. So it says parts A through F are similar to a puzzle that is more than 2,100 years old. Mathematicians first created the puzzle in ancient India in the 2nd century BCE. More recently, about 700 years ago, Muslim mathematicians created the first tables, allowing them to locate answers to this type of puzzle quickly. Tables similar to them appeared in school math books until recently. Here are some clues to help you figure out how the puzzle works. So what this is, it says log, with this little 2 down here, we read as a base. So log base 2 of 8 equals 3. This one, log base 3 of 27 equals 3. Here, log base 5 of 25 equals 2. And then this one, log base 10 of 10,000 equals 4. So those are your clues as you're trying to figure out the missing pieces of these puzzles. So you have to think of it from a math point. Again, log base 2 of 8 equals 3. Log base 5 of 25 equals 2. So take a minute, see if you can figure that out. See if you can figure out, if you can get A through F, awesome. If not, see if you can just figure out what's going on in any of these top 4 examples. So here are the examples again. Here, I didn't write the question marks, I just left them as blank spaces so that we could fill them in. Just real quick in the chat, how many of you think you know what's going on? You think you like see the pattern? Yes, no, or I think so, but I'm not sure. Like, where are we at? Do you see what's going on? And you can type it privately or to the whole class, it doesn't matter. And some people will see it and some won't, just like any type of puzzle. So I just need, please, from everybody, yes or no, or I think so, maybe, I'm just not too confident. So, and we're definitely going to practice this more. This is the first time you're seeing it. So I said, think back about what we were doing over here. Sorry, we were talking about an exponential and then we talked about its inverse. So if you think, how are the numbers 2, 3, and 8, 2, 8, and 3 related? How are the numbers 5, 25, and 2 related? How are the numbers 3, 27, and 3 related? How are the numbers 10, 10,000, and 4 related? So we know, and I think this one might be the easiest, the numbers 5, 25, and 2. We should know that they're related because 5 squared equals 25. On this one, 2, 8, and 3, hopefully we recognize that 2 to the third power equals 8. On this one, 3 to the third power equals 27. And this last one, 10 to the fourth power equals 10,000. So the way these logs work is here you're saying log base 2 of 8 equals 3. So you're asking yourself, this is very similar on part A, you ask yourself 2 to what power is going to give me 16? So 2 to some power gives me 16. That's how you're filling these in. On part C, the question mark is here. So you're saying, okay, that base, whatever that base is, the power of 2, that gives me 100. Whatever the base is the base down here. Whatever it's equal to is your exponent. And then inside your parentheses, whatever you're taking the log of, that's the number that should be by itself. So see if you can take a minute to figure out any of those ones, fill in any of those blanks. A through F. See if you can get those. So on A, we're going to have 4 because 2 to the fourth power, see that, I made that box. So because 2 to the fourth power is 16. On B, you're asking yourself 2 to what power is 32? So this one is going to be 5 because 2 to the fifth is 32. Log base what of 100 is 2. So what number squared gives me 100? That's going to be a base of 10. 10 squared equals 100. Here you're asking yourself, so it's log base 5 of something equals 3. So that's following the pattern 5 to the third equals some number, which 5 to the third we know is 5 times 5 times 5, 125. Here we're saying, okay, log base something of 81 equals 4. So some number to the fourth power equals 81. So what number do you multiply together 4 times to give yourself 81? That's going to be a 3. So log base 3 of 81 is 4. And then here, this one's a little bit trickier. Log base 100 of 10 is equal to what? So this problem is 100 to some power is equal to 10. And we need to know what that power is. So here, this is going to be to the 1/2 power. Because if it's going down, it has to be a number less than 1. So log base 100 of 10 is equal to 1/2. So like I said, we're going to practice more of this. We will get notes on this someday this week. This is the first time you're seeing it. So if it's not like perfectly clear, that is okay. But for problem 55, so we were focusing on y equals 3 to the x a couple of minutes ago. Back here, I'm going to flip the page back. When we did this problem, and we saw that this was the inverse, and we kind of asked ourselves this same question. 3 to what power gives us 81 when we were trying to fill in the table or find the missing value? So here, for y equals 3 to the x, the inverse, we said is x equals 3 to the y by just switching x and y, but that's equivalent to y equals log base 3 of x. So if you think about this and this, these are exactly what we were doing right here. 3 to some power equals x, just like right here. So the 3 here is the 3 here. It's a little 3 on the log. The exponent is the number by itself. And then the number that was by itself is what you're taking the log of. Do we have questions before we go to the next part? So let's see, I have a couple of chats. Yes, so these are the same exact thing, just written 2 different ways. Let me see if I can find the page in our book. And we will take notes, like I said, I think tomorrow, but just to show you, I wanted to try to use the same letters in your book to be consistent. But yeah, you just switch where everything is. The base on the exponent is the base of the log. Yes. All right, so we're moving on to 5-63, which is going to continue working on these logs. So let me share the book with you so you can copy that table down. That's not what I wanted to share. So you're gonna copy this table down. I'm gonna also copy it down. And they're not in order, which I do think makes this problem harder. I don't love the way your book did it.
little dirty and delicate.
Okay.
You didn't wash it very good. You don't know how to wash the bit very good.
So if you can fill in some of this table, again, think about what we were just doing. I can show you my paper because it has the table on it also. So think about what we were just doing up here using the idea of the exponential and the log to see which of these you can fill in. And if you know one or two of them, will you type it in the chat and I will add them to my table for the people that are kind of stuck? Because sometimes once you see a few more, you might be able to fill them in. So the only three numbers we have, three ordered pairs we have so far is when x is 8, y or g of x is 3. So if x is 8, y is 3. If x is 1/2, y is -1. And if x is 64, y is 6. So again, if you know one or two of these to fill into the table, will you let me know? I'm not necessarily asking for the equation yet. We will do that in just a second. A couple of you gave me the equation and thank you, but just a couple so that we can help people try to figure the rest of these out. So if x is 32, someone just told me y is 5, and that's correct. If x is 1, y is 0. Yes, if x is 16, y is 4. I think 3 or 4 people just told me that next one. So those of you still stuck, there's kind of, see if those help you. But A says describe an equation that relates x and g of x. So g of x is the exponent needed to get x when the base is 2. So g of x is the exponent needed to get x when the base is 2. So basically, x equals 2 to the power of, I'm just going to write y instead of g of x. But x is, so here, 4 is equal to 2 to some power, which would be 2. Here you're asked for the 3. This is a tricky one. It's not a whole number. You're asking yourself 3 is equal to 2 to some power. And on a problem like this, you can just guess and check on your calculator. Doesn't have to be perfect, but that's what you're asking yourself. Two equals 2 to some power. This one was 64 equals 2 to the power of 6. So again, for this one, it would just be 1. If we wanted to know 3, again, you can just guess and check. Oops. Sorry, I hit the wrong button on my calculator. But you could just, we know 2 to the power of 1 is 2, 2 to the power of 2 is 4. So you could guess somewhere in between. So 2 to the power of 1.5, that's close to 3, 2 to the power of 1.6. So you could round that to about 1.6. Again, it's not perfect. This one is tricky with the 0. You're asking yourself, remember, x is by itself. 0 is equal to 2 to the what power? So what power can you raise 2 to get 0? And we should know it's not possible. No matter how many 2's you multiply together or divide by, you're never going to get 0. The other way, don't confuse it with this one. This one over here is 1 equals 2 to the power of 0. We can have an exponent of 0. We can't have an x value of 0. This other one is also not possible at -1. You can never have, again, if you're taking a bunch of 2's and multiplying them together, you're never going to get a negative output. This one, you're asking yourself, 0.25 is 2 to what power? So this is -2. Here is 1/2. I'm just going to fill these in to kind of make it, hopefully it's making sense. So we could just rewrite them all in this form. And as of now, yes, the only way we can do these trickier ones like 3 is guess and check. Our goal is moving away from that, but that's the only thing we can do right now. 0.2 is about -2.3. Sorry, I didn't have much space, but it's negative. Your exponent is allowed to be negative. So this one here, I don't have very much room. 0.2 is equal to 2 to the power of -2.3. Remember, negative exponents give you a number that's less than 1 in this case. And then 1/8 is -3. I did that one in blue. That's okay. So what we were really asking, remember, just like we wrote this here, if I write this in log form, that's y equals log base 2 of x. These are the exact same thing, just written in a different form. This is exponential form. And this is log form. So those are equivalent. Okay, questions on that one? So again, we were doing the exact same thing. They were just giving it to us in a table form and not like up here, we were given it in log form, and here we had to kind of guess and check to figure out what was going on. But it's the same thing. So on problem 64, I don't want to do the whole thing because it's very similar and it's filling in a table. it says Lynn is supposed to fill in a table for g of x equals log base 5 of x. So they're giving us that it's a log equation. She thinks she can use the log button on her calculator. So I'm just gonna not copy this whole table down. So 1/25, let's see. I'll just do the first few. 1/5, 1/2, 1, 2, 3, 4, 5. I guess I'm ending up doing most of it, that's okay. And then they give us 5 as 1. There's a few that they give us. I'll just do 10 also, and then I'll skip to 25 is 2. And then 100 and 125. They give us 125 is 3. So I really just skipped 6, 7, 8. Sorry. But it tells you Lynn is using the log button on her calculator. So if you notice, oh, they also, a few of these were filled in. I didn't even pay attention. 1/5 was -1 and 1 was 0. So if I type in, let's say, log of 5, just to check, I know I should get 1. The book tells me I should get 1. But when I do that, I don't get 1. So what you can do here, we could guess and check, but we don't want to do that. That's going to take a lot of time. The way to do this is there's a different button on your calculator. You have to hit math. I think it's math. Hold on. Oh yeah. So you hit, let me do that again. You hit the math button. You scroll down or up, it's quicker to scroll up, and you need log base. Because when you type it in without a base, it doesn't, we know the base is 5. So we'd have to type in log base 5 of 1. And that's where we get 0. Because remember, this you're really asking yourself, 5 to what power gives me 1? Here you're asking yourself, 5 to what power gives me 1/25? So to type this in, we could guess and check this way, or we can type it in like this. Again, math, go to the log base. So log base 5 of x, x is 1/25, and we get -2. 5 to the power of -2 is 1/25. I'm just going to copy and paste that. Instead of 1/25, I want 1/2. So log base 5 of 1/2 equals -0.43. So notice these ones are filled in because they're multiples of 5. Or not multiples of 5, I'm sorry. They're multiples of 5, yes, but they're how many times you multiply 5 together. 5 squared is 25. 5 cubed is 125. Don't be confused here with the 10. You're asking yourself with the 10, 5 to what power equals 10? So it's how many 5s do I have to multiply together to get 10? It's not 2. It's not 5 plus 5. 5 times 5 is 25. And now that these ones are in order, you can see that it has to be between 1 and 2. So again, math button, the log base 5 of 10. So that's 1.43. That means 5 to the power of 1.43. I rounded that, but that's going to be about 10. If we round this, we get 10. So we can see that these numbers are going up, but they're going up slowly, right? We went, when x was 5 all the way to 25, we just went from 1 to 2. When x was 25 all the way to 125, we went from 2 to 3. This one at 100, I'll tell you, would be 2.86. So as x increases, y, or g of x, or y, increases slowly. It's still increasing, but it's going up very slowly. I could fill all of these in. They're numbers between 0 and 1, and they're increasing, not a super big deal. And if I think about this graph, x cannot be 0. Just like we saw right here, it's not possible. This one just had a different base. X cannot be negative. If I make x's smaller, I'm going to get this asymptote here. So this is our log graph. The inverse of an exponential is a log. And we can see that this is the asymptote. I didn't draw it very good. So that's why x cannot be 0 or negative numbers. And tomorrow we're going to focus on log graphs a lot more. So don't stress about that part too much. This is if I plotted all of these ordered pairs in this table, that's what it would look like. All right, we're just going to do a couple more because I don't want to keep you guys too much longer. So on 65, it wants you just to practice rewriting these in exponential form. So log base 2 of 32 is equal to what? The log base 2 of 1/2 is equal to what? C log base 2 of 4 is equal to what? They want you to write y. So I'll show you log base 2 of 0 is equal to what? So here on A, you're asking yourself 2 to what power is equal to 32? You can do these on your calculator, but you shouldn't have to. These ones are ones you should be able to do without your calculator by practicing writing them in exponential form. So you're asking yourself 2 to what power up here is equal to 32? How many 2's do we have to multiply together to get 32? So 2, 4, 8, 16, 32, 5. So log base 2 of 32 is 5 because 2 to the 5th equals 32. Here you're asking yourself 2 to what power equals 1/2? These are the trickier ones when it's going down. So this is going to be -1. 2 to the power of -1. Remember, negative exponents, those are the reciprocals. So log base 2 of 1/2 is equal to -1 because 2 to the power of -1 equals 1/2. Log base 2 of 4 is equal to what? What do we have there? Yeah, a few of you said it. It's just 2 because 2 squared is equal to 4. What about D? D's a little bit trickier. So on D, you're asking yourself 2 to what power is equal to 0? That's kind of up here. That's your little question mark. Oh, I have the answers right there next to you, sorry. So this one is not possible. You can't raise 2 to some power and get 0. And then we're gonna skip E through H and just do A and B on 66. So on 66, they give us the equation y equals log base 9 of x. And then B is y equals 10 to the x. And they want us to write the inverse. So they don't want us rewriting it. Here we were rewriting in exponential form. Here we want the inverse. So the inverse switches x and y. So here my inverse is x equals log base 9 of y. But they want it in y equals form. So again, inverse, we switch x and y. So here my inverse, you're just switching x and y. X equals 10 to the y. But we have to write these in y equals form. So that's how we would type them into our graphing calculator. So now is when we switch it. So if this is x equals log base 9 of y, that's equivalent to y equals 9 to the power of x. Right? The base on the log is the base of where you have the exponent. The number by itself is the exponent, and what you were taking the log of is now by itself. So the inverse is y equals 9 to the x. Again, we can write it this way, but if we want it in y equals form, it looks like this. Same thing here. If I want the inverse in y equals form, here it's an exponential form. If we want to go to log form, it's going to be y equals, remember the exponent, that's the number that ends up by itself. Log, whatever the base of the exponent was, that's the base of the log. And then of x. These right here are equivalent. It's just two different ways to write the inverse. So if you want to write the inverse of a log or an exponential, you just switch x and y. But if you need it in y equals form, then you have to convert the other way. So I know that was a lot. What you should be walking away with today is knowing that logs and exponentials are inverses. And what a log is you're asking yourself, how many times do I have to multiply that number together to give me the base? How many times do I multiply the base together to give me that number inside the parentheses? So here you were saying, how many 2's do I multiply together to get 32? How many 2's do I multiply together to get 4? So that's the idea of the log. We can rewrite it in exponential form, but that's what's tricky. You can rewrite it in exponential form, but the inverse is also an exponential. It just looks a little different. We're going to work on these more tomorrow. You do have a few of them in your homework tonight, where you're mostly just changing forms. And I think you have to make one table. That one might not, but it doesn't have you do logs. So I think the only log, your first two problems are your logs. If you have questions, bring them tomorrow. Sorry, this was a little bit longer today. If you have questions now and want to stick around, if I went too fast, I am happy to stick around. Otherwise, you guys are free to go. Your homework is 68 to 74, and I will see you tomorrow at 10 a.m.